Hello all. So today we'll discuss about paratautomerism, right? So it is exhibited by mm, compounds which are dienone, right? It exhibits paratautomerism, right, in presence of a base. If you have a base, it can go about abstracting hydrogens and go about exhibiting tautomerism. And the product which was formed here was a very popular organic compound which is nothing but a phenol. Yes, this is my phenol, and this is nothing but my dienone system, dienone. Okay, so what I'm gonna say now is, can I tell with respect to the ketone, this ketone which is nothing but a functional group, there are two alpha hydrogens, one here and one here. But you also know that alpha hydrogens can't be abstracted when you have sp2 hybridized carbon atom attached to it, right? When you have sp2 hybridized carbon atom. So as you can see, sp2 hybridized carbon atoms are bearing hydrogens here, right? So this cannot participate in tautomerism. So now what will happen is, can you see with respect to this functional group in para position, you have two more hydrogens, right? There are two more hydrogens, right? So here these two hydrogens with respect to this functional group, which is nothing but ketone in this case, these hydrogens are going to get abstracted by this base, right? So talking about the mechanism, I'll just show you a general mechanism here so that you can understand regarding this, right? So I'll just draw the mechanism here in simple. Okay, so what happens here is, you have your dienone. Yes, this is my dienone, and there were two alpha hydrogens there were two hydrogens with respect to this functional group, right? Ketone is a functional group, and there we had a base, correct? This base, what it will do is, it'll just go about abstracting this hydrogen, right? It will just go about abstracting this hydrogen, and when this bond cleaves, the electron density will shift in here, right? So can I tell, in this particular compound, the negative charge will just come and get settled here. Yes, negative charge has come and settled here, correct? So now what happens here is, in this particular thing, can I tell, because of this negative charge, the electron density of this negative charge will come and shift in here, this will shift in here, and this will shift in here. I've just shown this step in a single step itself, so that this resonance, I've shown it in a single step so that things are pretty clear to you, right? So can I tell, this is what the structure which will be formed out of what I have made, right? So this particular structure which will be formed, correct? So can I tell, this is my phenoxide ion, very popular, right? Yes, phenoxide. So this is what my phenoxide is, and this phenoxide, when you're treating with H2O, HOH, right? When you're treating that with HOH, what will happen? What will happen when you're treating that with HOH? H has delta positive charge, you also know that, right? Can I say oxygen will have delta negative charge because of its polarity which is existing? So this negative charge will just go about attacking this H plus center, and what will the product form? It will just be a phenol, guys. It will just be a phenol, right? So this is what our product formed. And can you see here, OH, this particular OH, this particular OH, this particular OH is again generated in this reaction. So we started from OH negative itself. Can you see? We started from here itself, and again we ended up generating OH negative, correct? So this is pretty much about our paratautomerism, right? And as per Lee-Chatlis principle, can you see, from dienone we are trying to form a phenol, and this reaction is favoring towards product side, right, as per Lee-Chatlis principle. So please keep that also in mind. And this is one such exceptional case which you can say, because you already know sp2 hybridized carbon atoms cannot show carbon atom bearing alpha hydrogens cannot show tautomerism, right? But this compound showed, because it can exhibit a phenomena which is called as paratautomerism, right, guys?